Imagine a planet where the oceans stretch as far as the eye can see, where the air is thick with gases that might be produced by living organisms, and where the atmosphere itself hints at conditions even more suitable for life than Earth. No, this isn't the setting of a sci-fi movie. This is K218b, a real exoplanet discovered by the James Webb Space Telescope, JWST. The question is, could this distant world harbor life? K218b is no ordinary exoplanet. It's what scientists refer to as a super-Earth. A planet larger than Earth, but smaller than the ice giants Uranus and Neptune. K218b is about 2.6 times the size of Earth, and it orbits a star in the Leo constellation, roughly 120 light-years away. While this may sound impossibly far in human terms, it's relatively close in astronomical distances, making it one of the more accessible targets for studying potentially habitable worlds. What makes K218b particularly intriguing is its location within the habitable zone of its host star. This is the sweet spot where temperatures could allow liquid water to exist, one of the essential ingredients for life as we know it. In addition to its size and location, the planet's atmosphere is rich in hydrogen, which has sparked interest in its potential to harbor life-supporting gases. This is where the James Webb Telescope, JWST, comes in, a technological marvel. The telescope can peer into the atmospheres of distant worlds with unprecedented clarity using a method called transit spectroscopy. As the planet passes in front of its star, James Webb Telescope breaks down the starlight, filtering through its atmosphere to reveal what gases are present. When applied to K218b, the results were nothing short of astonishing. Methane and carbon dioxide, gases that, on Earth, are often associated with life. On Earth, methane is largely produced by biological processes. Cows, bacteria, decaying plants all contribute to methane levels in our atmosphere. Although methane can also result from non-biological sources, like volcanic activity, the specific combination of gases detected on K218b suggests something more. The levels of methane and carbon dioxide don't align with what we would expect from purely geological processes, raising the tantalizing possibility that life could be contributing to the planet's atmosphere. Even more compelling is the potential discovery of dimethyl sulfide DMS, a compound that, on Earth, is exclusively produced by living organisms. Marine phytoplankton, tiny plants floating in our oceans, are the primary producers of DMS. If this compound is truly present in K218b's atmosphere, it could be a stronger indicator of life than methane. However, this discovery is still preliminary, and more research is needed to confirm DMS's presence. K218b isn't just any super-Earth. It falls into a specific class of exoplanets known as Hycean worlds. These planets are theorized to have vast global oceans and thick, hydrogen-rich atmospheres. While Earth's atmosphere is mostly nitrogen and oxygen, K218b's hydrogen-dominant atmosphere could still support life, albeit life forms very different from those on our planet. In fact, some scientists speculate that Hycean worlds might actually be better suited for life than Earth. The hydrogen-rich atmosphere could provide a stable, warm environment, while its thickness might protect any potential life forms from harmful space radiation, similar to how Earth's atmosphere shields us from solar and cosmic radiation. Life on K218b, if it exists, would likely be aquatic and microbial, possibly evolving in ways that we can't even begin to imagine. However, it's also possible that the planet's deep atmosphere and high pressures at the surface make it more like a mini Neptune, meaning any life forms would need to withstand extreme conditions. The discovery of planets like K218b hasn't always been easy. Detecting exoplanets, worlds orbiting stars outside our solar system, was practically impossible until the mid-1990s, when astronomers began using methods like the transit technique. By observing stars for tiny dips in brightness as planets pass in front of them, scientists could infer the presence of a planet. Another method, radial velocity, measures the wobbling of stars caused by the gravitational pull of orbiting planets. Since those early days of exoplanet hunting, over 5,000 such planets have been discovered. However, the atmospheres of most of these worlds remain largely mysterious. This is where the James Webb Space Telescope changes the game. Its infrared capabilities allow it to peer into the atmospheres of distant planets, breaking down their chemical compositions with precision. In the case of K218b, JWST's detailed observations of methane and carbon dioxide ratios suggest something biologically intriguing might be happening. It's important to approach these findings with caution. Methane and DMS, while exciting, can also be produced by non-biological processes. Volcanic activity, for instance, can produce methane, and in some rare cases, DMS can come from other natural chemical reactions. Moreover, even if life does exist on K218b, it may not be the complex or intelligent life many of us imagine. Microbial life, which thrives in extreme environments on Earth, could very well be the most advanced form of life on such a distant and alien world. In addition, the vast distance separating us from K218b, 120 light-years, means that sending humans or even robotic probes to the planet is, for now, a far-fetched idea. With current technology, it would take thousands of years to reach K218b. However, future initiatives like Breakthrough Starshot, a project aiming to send tiny, lightweight probes to nearby star systems, could one day make it possible to explore such planets more closely. Even if we don't physically reach K218b anytime soon, studying its atmosphere with powerful telescopes like JWST brings us one step closer to understanding its mysteries. K218b is just the beginning. The James Webb Space Telescope is expected to continue its search for exoplanets, each with the potential to harbor life. Future discoveries might include planets with oxygen-rich atmospheres or artificial light signatures, signaling the presence of advanced civilizations. The possibilities are vast, and each new discovery brings us closer to answering one of humanity's oldest questions. Are we alone in the universe? As scientists continue to analyze data from K218b and other exoplanets, our understanding of what makes a planet habitable is evolving. Life might not require Earth-like conditions to thrive. Instead, it could survive in environments that are radically different from what we're used to, expanding our ideas of where and how to search for it. The discovery of K218b and the detection of potential biomarkers like methane and dimethyl sulfide mark an exciting new chapter in the search for extraterrestrial life. While it may be too early to declare that life exists on this distant world, the possibility is enough to ignite our imaginations and push the boundaries of scientific exploration. The James Webb Space Telescope, with its incredible ability to observe distant planets in detail, is just beginning to unveil the secrets of the universe. K218b is a reminder that we are living in a time where the search for life beyond Earth is not just the stuff of science fiction, but a real scientific pursuit. Who knows what other discoveries await us? As we continue to explore the cosmos, one thing is certain: the universe is vast, mysterious, and full of possibilities. So, while K218b may not have little green men waving at us from its shores, it could be home to life forms that challenge everything we know about biology. Keep looking up, because the answers we seek may be closer than we think. If you enjoyed this video, don't forget to hit that like button, share it with your friends, and subscribe to the channel. And of course, tap that bell icon so you never miss out on any of our cosmic adventures. Thanks for watching, and I'll see you in the next video.